In this video, we're going to be discussing the distance formula. Yes, how do we calculate the distance from here to here numerically? So first, in order to understand the distance formula, we need to revisit the Pythagorean Theorem, which is something you should have already come in with. So right here in this spot in your notes, right in this blank space, I would like for you to get all of this information. So feel free to press pause after I'm done talking, and you can copy this in. But a squared plus b squared equals c squared is what you know of the Pythagorean theorem. Now let's unpack this a little bit. Where are a and b on a right triangle? So if we had a right triangle, and here's the right angle, across the street from the right angle is that's an arrow, is the hypotenuse. That is what you've formerly known as C. Over on the other sides are the legs, and you've known these as A and B. Whoops. And so A and B are the legs of a triangle, right? So right here and right here, these are the legs of a right triangle. The longest side is the hypotenuse, right? It's the hypotenuse. That's the longest side. So make sure you have everything in white written into your notes and maybe a little quick sketch of that right triangle in this space right here, and then we can get going. So in this video, we're going to discuss how to describe the distance numerically from this point here to this point on this segment. Now, he said, well, I guess what happened to the right triangle? Well, we could form one. We could force one to happen right here by just drawing in the legs. And this would be a leg, and a hypotenuse. And you'd say, well, this leg is 3 boxes long, so that's 3. And this one's 1, 2, 3, 4, 5, 6 units long, so that leg is 6. And the hypotenuse is what we're going to refer to as x. So we say, well, the Pythagorean theorem says a squared plus b squared equals c squared. One of the legs is 6, so I'm going to square that. The other leg is 3, so I'm going to square that as equal to the hypotenuse c squared, or if you want to call it x squared, what have you. Now, we're going to follow our order of operations. So 6 squared is 36, 3 squared is 9, and c squared just remains c squared. Now I add 36 to 9, and I get 45 is equal to c squared. But I don't want c squared, I want the value of c. So how do I undo squaring? I take the square root. Algebra says whatever I do to one side, I do to the other. And then I grab a calculator and I round this off to the nearest tenth, and I arrive at approximately 6.7. So the length of said box over here, right? So now I can sort of erase all this and say, well, you know what? This length is approximately 6.7 units. Now, as you count diagonally, you can't really count whole boxes, but you know, this is a little more than a box, and you got another little more in a box that's like 2, and in this box, sort of like 3-ish, 4-ish, 5-ish, 6-ish. Yeah, that seems to make sense. The other thing I know too is this is the longest side. If this is 6, it looks a little longer than 6, and again, that makes sense. What the distance formula does is converts Pythagorean theorem leg lengths and allows us to just use coordinates. So let's attempt that. So let's get into the actual formula. So let's say you have 2 points. Let's say these points are A and B. And A is located where? At some xy coordinate, and B is located at some other xy coordinate. We're going to call those coordinates x1, y1, x2, y2. You should remember utilizing that notation from algebra. So we're going to say AB, remember, this is the length of segment AB. AB is going to be equal to, and we're going to put a big square root, and then we're going to put a set of parentheses, and another set of parentheses, and we're going to add what's in those parentheses, and we're going to square what's in those parentheses. And what's in there? The difference of x2 minus x1, and the difference of y2 minus y1. And so what do we get when we're doing this? Let's take a look. First, let's go to your number 1 here, and let's label this point with coordinates. Now I know I go 5 left, so that's -5, and 1, 2, 3 up, that's +3. And keep in mind that this is my x1, y1. Down at the other point here, I see that I went 2 left and down 3. So that's going to be -2, -3. That's my x2, y2. And I call them x1 and y1 and x2 and y2 because it was the first point and the second point. It doesn't matter which one you dictate to be which set of x1, y1, just like in slope. Now again, let's label this A and let's label this point B. So the distance between AB is going to be the difference of the x values. So we said x2 minus x1. x2 is going to be -2 and x1 is -5. So I come up here and I say -2 minus a -5, all squared plus. And it might be handy just to write everything that's not going to change in this formula. You can put the parentheses, you can put the big square root, you can put the squared sign, you can put the plus, you can put the minuses in there. The only thing you can't put is the actual values. So notice in the second part, I kind of have everything all set up. And now I'm just going to substitute in the y values. Okay, so I go in and I say y2 is -3 and y1 is +3. Now what? I'm going to make a big square root again because nothing's going to change there. And I'm even going to leave the squaring. All I'm going to attempt in the first level here is the actual subtraction. And -2 minus -5 is -2 plus 5, which is 3. And -3 minus 3 is -6. Now, remember my example that I did just prior to this? I said, hey, let's make this a right triangle. This is 3 units long. This is 6 units long. Look who showed up to the party. The leg lengths. Now they're disguised. Maybe some of them might still be negative. That's okay. We're going to take care of that right here. 3 squared is 9. -6 squared. I'm not going to put the negative in my calculator. I'm just going to square 6 if I need help. But I know that to be 36, which is the square root of 45, which is approximately, you guessed it, still 6.7. So AB is approximately 6.7 units long. Let's try that again. So the first thing I'm going to do, you don't have this graph, right? You don't need this. This is just going to show you how this all comes together. The first thing I want to do is on my paper, I want to go underneath and I want to call this x1, y1, and this x2, y2, right? Good labeling promotes good endings. They already have them labeled A and B. If it was C and D, I'd write CD. If it was, MN, I would write MN. They're using AB, so I'm going to say AB is equal to. And I'm going to write the formula. Again, all squared plus all squared with a minus in there. And now what goes inside those parentheses are actual values, right? So x2, x1, y2, y1. It should be noted that I could also write x1 minus x2 and y1 minus y2, right? The ones and the twos don't matter as long as if I start with one here, I start with one there. Okay, so just be consistent. All right, so let's get rid of that and let's start substituting in values. Now again, I'm just going to change colors to all white here so it can stick out a little better. And I'm going to say AB, open parentheses, squared, plus open parentheses, squared, minus in the middle, minus in the middle. I have my values labeled, right? And I want to write this formula on every page that I'm working on. Maybe not on every problem, but I want to write it right across the top of the page so that I'm just referencing this formula card, right? You don't need to memorize it. You just need to apply it. Okay, so my x2 is 3. My x1 is -4. Notice the negative is not the minus sign. It's an additional minus sign. So y2 is -1 and y1 is +1. All right, I'm going to come down one layer here and I'm going to make a big square root. I know that I still have to add the squares of these things, so I'm just bringing everything that's not going to change. And 3 minus a -4 is 3 plus 4, which is 7. -1 minus 1 is -2. Come down another layer. Right? It's all about just taking my time, writing everything out. 7 squared is 49. -2 times -2 is +4. That's going to be the square root of 53. So my last line is not going to be an equal sign because I'm rounding, so I'm going to put about. And the square root of 53 is about, according to my calculator, 7.3. Now, what I'd like to do is to plot this on the graph to see what happens. So we went -4 left and up 1. That's point A. For B, we went 3 to the right and down 1. There's 3, down 1. What we're trying to dictate is how far that is. Well, if I created a right triangle out of this, I think I would go down 2 and over 7. This leg would be 7. This leg would be 3. And what we're looking for is this, right? So if I said a squared plus b squared equals c squared, I think I'd say 3 squared plus 7 squared equals c squared. Or 9 plus 49 equals c squared. Or 53 equals c squared. Square root of 53 should be approximately what c is, which is, still 7.3. So the Pythagorean theorem is great for when I have actual segment lengths, right? If I'm dealing with lengths of tangible segments, it's easy to just count boxes or bunny hops there and get the lengths. When I'm just given coordinates, then my coordinate form of determining distance between 2 points will be to use this formula. So now I have additional tools to find lengths. Let's try one more. This time, no handlebars on the graph. I'm just going to label x1, y1, x2, y2. Again, I have that formula written at the top of my page, and I just commenced to copying, right? So first things first, it says that these points are E and F, so I'm going to write EF because I'm not going to be a robot. I'm going to think about what's been given to me, and then I put everything that's not going to change so I don't screw anything up. Notice I don't skimp on anything. I draw the whole square root sign all the way over. Right? See, a lot of students do this and then write a bunch of scribble after that. And then guess what they forget to do at the end? They forget to take the square root. And of course, right, I have sort of low empathy, right? Because, right, you can even get the second row going. If you skimp, you'll tend to make a mistake. All right, now let's go back and start substituting in. X1 was -7. And x2 was 11. So x2, 11 minus -7. y2, 3. y1, -2. 3, -2. See? Because I've already set up my whole scenario, I'm not thinking about too much. I mean, I'm thinking a little bit. You know, let's not think. Okay, enough of the jokes, Brecklin. All right, so 11 minus a -7 is 11 plus 7, which is 18 squared. 3 minus a -2 is 3 plus 2, which is 5 squared. And now we're going to write EF again equals big square root. 18 squared is going to give us 324. 5 squared is going to give us 25. We're going to add that together to get 349. And EF then is going to be, this time again, approximately, because we're taking the square root, approximately 18.7. Now, make sure that you can use the calculator, right? Do you know? Can you take the square root on a calculator? Make sure that you have that squared away. So we have 3 problems here. Now you're off on your own, and that's part of this section. See you next time.